You know, when you see a plane flying in a perfectly straight line, it looks so easy, right? But what you can't see is the constant, invisible battle the pilot is fighting. They're up against the sideways wind that's always trying to push them miles off course. So how on earth do they do it?
Well, it all starts with a question that seems simple but has a really complex answer. Imagine you're a pilot and you're trying to fly a perfect circle over a landmark on the ground, but there's a 10-knot wind constantly pushing you sideways. How do you pull that off? Because if you just held the same turn, the same bank angle, you wouldn't get a circle. You'd actually trace this weird, lopsided egg shape over the ground.
And this gets right to the absolute heart of the problem. A pilot has to think about two different paths at the same time. There's the path through the air, that's where the nose of the plane is pointing, where it thinks it's going, and then there's the path over the ground. Think of it like the plane's actual shadow. That's the one that really matters. And whenever the air is moving, those two paths are almost never the same.
And listen, we are not talking about some crazy hurricane force winds here. Even a gentle 10-knot breeze, that's about 11 miles an hour, is more than enough to shove a small plane 10 nautical miles off course in just 60 minutes. That's literally the difference between landing at the right airport and landing at one in the next county over.
All right, so this brings us to the first big idea: flying in a moving sky. You've got to stop thinking about wind as just weather. For a pilot, it's like flying inside a giant invisible river that's constantly flowing.
So how in the world do you fight an invisible current like that? Well, think about a boat trying to get straight across a river. The captain can't just point the nose at the dock on the other side, right? The current would just sweep the boat way downstream. No, they have to aim the boat upstream into the current. And pilots, they do the exact same thing, pointing the nose of the plane into the wind.
And that brings us to the pilot's toolkit. To really master flying in this moving river of air, pilots rely on two foundational rules. These rules let them predict and cancel out that constant drift. Let's dive in and break them down. Okay, first up, we've got to get our heads around a key term: ground speed. Now, this is not how fast the plane is flying through the air. It's how fast its shadow is moving across the ground. It's pretty simple, really. If you've got the wind at your back, that's a tailwind, your ground speed is way faster than your airspeed. But if you're flying into the wind, a headwind, your ground speed is going to be a lot slower. So here's how pilots put it all together. To fly a perfectly straight line over, say, a highway, they point the nose slightly into the wind. It's a technique called crabbing, just like that boat aiming upstream. But to fly a perfect circle, that's where the real artistry comes in. Since their ground speed is always changing during the turn, they have to constantly change how steeply they're banking. They'll use a steeper bank when they're moving fast with the wind, and a much shallower bank when they're moving slow against it.
And this is the key thing to remember. Pilots are not sitting up there punching numbers into a calculator. It's a skill of constant observation and adjustment. They're watching how the airplane is tracking over roads and fields, and they're making these tiny, continuous corrections to stay on their desired path. It really is a dance between the pilot, the plane, and the ground below. So how do pilots turn these rules into pure instinct? Simple. They practice. A lot. And it starts with a maneuver that directly mimics an airport landing approach. It's called the rectangular course, and it's all about flying a perfect rectangle over the ground. And there are a whole bunch of reasons why this is so important. It forces the pilot to split their attention between flying the plane and watching the ground. It's where they truly master those changing bank angles and the turns, and they learn how to roll out of a turn already pointing into the wind, perfectly set up for the next leg. This is the absolute building block for every single landing a pilot will ever make.
And right here, you can see that golden rule in action. When turning from the downwind leg, where your ground speed is at its absolute highest, the pilot needs a pretty steep bank to avoid shooting past their line. But when they're turning back into the wind with a much slower ground speed, they use a nice, shallow bank to make the turn just right. It's this constant flowing dance of adjustments. All right, now we're getting to the final exam of ground reference flying. This is the big one. It's a maneuver so demanding that it's considered the ultimate test of a pilot's intuitive control. It's called 8s on pylons. Now, to even get this, you have to wrap your head around a pretty mind-bending idea called pivotal altitude. For any given speed over the ground, there's one and only one altitude where it will look like your wingtip is literally pinned to a spot on the ground as you circle it. It feels like the entire world is revolving around your wingtip.
And here's the crazy part. That magic altitude, it changes directly with your ground speed. So for example, if you're doing 87 knots over the ground, your pivotal altitude is about 670 feet.
But if that wind kicks you up to 113 knots, you've got to climb to over 1,100 feet just to keep that wingtip pinned to the same spot.
So the rule is simple. The faster your ground speed, the higher your pivotal altitude needs to be. Now, remember what we said about the wind. It's constantly messing with your ground speed, making it faster and slower as you turn.
Okay, so this is where it all clicks into place. During this whole maneuver, the pilot isn't even looking at their altimeter. They just follow two dead simple visual cues. If the point on the ground, the pylon, appears to move behind the wing, they're too low, they need to climb. If that pylon moves ahead of the wing, they're too high, and they need to descend. Simple as that.
So what does this all mean? It means that as the pilot is flying this figure 8, the wind is constantly changing their ground speed. And to keep that wingtip perfectly pinned on that point on the ground, they have to be in a constant gentle climb or descent throughout the entire maneuver. It is the absolute ultimate act of synchronized flying, all done by feel.
Which brings us to the big question, right? Why go through all this trouble just to fly in circles and rectangles? Because it's not about the shapes. It's about what the shapes build inside the pilot. Because these maneuvers, they're not just about flying in shapes. They forge the absolute bedrock skills of a safe pilot. Things like division of attention, being able to manage everything inside and outside the cockpit, the intuitive, precise control you need to put the airplane exactly where it needs to be, and total situational awareness, always knowing what the wind is doing and how your plane is moving over the ground.
So hey, the next time you're on a flight and you look out the window as you're coming in for a nice smooth landing, maybe you'll see it a little differently. You'll know you aren't just watching a machine fly a straight line. You're actually witnessing the final result of a pilot's constant, invisible, and beautiful dance with the wind.